Hi doctor, my name is Fasihan with matrix number AF210121. At the beginning of this video, I would like to introduce my group project BFC34303 Engineering Statistics. Our group members are Alvin Rimalja AF210099, Chang Hongyu AF210111, Bang Zichuan AF210102, and Ko Binghua AF210089. We are from group 2. For introductions, traffic violations can be defined as an act that breaks the traffic regulations. For instance, speeding, improper parking, without signal actions, and many more. Traffic violations can bring consequences, normally cause road accidents, structural damage, and even culture ties. In this project, we collect the data of the number of vehicles without signal actions at the corner junctions near a secondary school, which locate at Jalan Bukit Gamina, Seremban, Negeri Sembilan. The types of vehicles that collected are motorcycles, cars, and lorries, and we collected the data in every 5 minutes interval for 1 hour in consecutive 2 days. Moving on to our objectives, in this project, we are able to analyze the data by using frequency distribution curves and box recurve plot, and analyze the data by using descriptive statistic and inferential statistic. Continuing for the methodology, our data is collected by observing the non-signaling of vehicles at a corner junction. The data analysis was done by finding the frequency distribution curves, box and whisker plot, F-test, and Z-test. Other than that, the type of data and measurement scalar for this statistic analysis is nominal data, which data represents distinct categories without any inherent order or numerical meanings. Hence, the data can be classified and counted, but no mathematical operations can be performed.
I'm Chang Ming. Now I will talk about the data presentation. The data is collected and tabulated as this table. The independent variable is time interval, and the dependent variable is vehicle with signal and without signal for each type of vehicle. Then the total number of vehicles with signal and without signal is totaled up according to the time interval. This table is built to easily calculate the mean, mode, median, variance, standard deviation, and 25-75 percentile. This is the frequency distribution curve. The frequency distribution curve for the total vehicle in first day, the graph of without signal is more consistent than with signal. This graph shows the total vehicle in second day. The graph of without signal is more consistent than with signal. This is box and whisker plot of total vehicle with signal and without signal in first day. Both is positively skewed. This is box and whisker plot of total vehicle with signal action and without signal action in second day. With signal is negatively skewed and without signal is positively skewed.
Hi, my name is Alvin. This is the F-test for 2 population mean, which is also known as ANOVA test. This is the result table, and before doing the test, we are going to do the assumption. So the null hypothesis is all the mean number of vehicles with signal action are all equal, and the alternative hypothesis is all mean number of vehicles with signal action are not equal. So based on the result calculated, since the calculated F is greater than the critical F value, so we reject H naught. So therefore we accept the null hypothesis, which states that the mean number of vehicles with signal action are not all equal. The mean number of vehicles with signal action is not the same in each group. It is likely that the number of vehicles with signal action is related to the attitude of the driver. This is the F-test for 2 variances. So this is the result table. We do the assumption where the null hypothesis is sigma 1 square equal to sigma 2 square, and the alternative hypothesis is sigma 1 square is not equal to sigma 2 square, where the sigma 1 square is the variance of the number of vehicles with signal action of 4 mA, and the sigma 2 square is the variance of number of vehicles with signal action of 5 mA. So this is the result table. So based on the result calculated, since the calculated F is less than the critical F value and do not fall in the rejection region, so we do not reject H naught. So we accept the H naught, which is the null hypothesis, which states that there is no difference in the number of vehicles in 2 days.
My name is Ko Binghua. I will continue with analysis and result. For comparing population mean for 2 independent samples, first denote mu1 equals to population mean of vehicle with signal action in day 1, and mu2 equals population mean of vehicle with signal action in day 2. Based on the previous calculation, we can get the information of x bar, s, and n. First, state the hypothesis of h null and ha. For ha is mu1 is not equal to mu2. Then the significant level, 95% significant level, 0.05 for alpha and 0.025 for alpha over 2. Step 3, identify test statistic. Since the population mean is not normal distribution, the sample is large, therefore Z distribution is applied. Based on the alternative hypothesis, we can see that we are using 2-tailed test, alpha over 2 equals to 0.025. Based on the standard normal distribution table, we can check the Z critical equal to 1.96. Step 4, formulate decision rule. if Z critical falls in the rejection region, which is Z bigger than 1.96 or Z smaller than negative 1.96, therefore we reject H null. Step 5, make a decision. We calculate Z calculated using the formula and we get the answer is 0.073. Step 6, make a conclusion. Since the Z calculated equals to 0.073 is less than Z critical equals to 1.96, then we accept H null that states that the population mean of vehicle with signal action in day 1 is the same as day 2.
I'm Bang Zikwan. Now I'm going to present the discussion for our group project. In this project, we are assigned to conduct a statistical analysis on terms of traffic violation, and the selected topic was vehicles' signal actions. Based on the result above, we can see that the mean value of vehicle with signal actions were higher than the vehicle without signal actions. It is important to conduct the statistic analysis of signal action in vehicle several for future use. Firstly, it is important to the road safety. By understanding the pattern and behavior of vehicle signal, it helps to identify the factors that contribute to accidents and near-miss incidents. The data analysis is also important for traffic management. By studying pattern of red light usage or turn signal activations, traffic engineers and urban planners can gain insight into traffic flow, congestion, and driver behavior. In conclusion, the location for data collection was at the junction near a secondary school in Jalan Bukit Kalena, Seremban, Negeri Sembilan. The location is selected due to road safety issues. Signal actions are important for drivers to communicate their intended action to other road users. Signal action provides important information to other drivers, pedestrians, and cyclists, allow them to anticipate the driver's action and adjust their own behavior accordingly. In addition, students are the road users when school starts and school ends. It is important for drivers to provide signal actions to avoid accident and confusion in the periods.